Alright, the first part from problem set 6 is the column support. This one is an equilateral triangle. The distance on all sides of the triangle are the same. The angles in between are the same. We have a polygon tool that will help in creating this. What we can do is we can offset. We also need to have the diameter these three circles are on and this shared radius on all three corners. We construct triangles using the polygon tool in a couple different methods. Circumscribe and inscribe, and this is based on the diameter of the circle. You can change this. You can change the dimensions, but you can't flip back and forth. You have to choose it ahead of time. So one option is to then use the offset tool. If I make an equilateral triangle for the distance between each of these, I could then offset it equal distance away. For the ribs, if we create a plane down the middle, we can create one rib, and then we can use circular pattern. One common mistake is this hole, the large diameter hole. This does not go all the way through. It is 32 millimeters deep. So keep that in mind. This does not bore all the way through. So in the end, we'll end up with something like this. But let's get started on this one. So a new design in inches. Sorry, this one's in millimeters. In millimeters. And using our polygon tool. Also, referencing the origin would be of great benefit as well. The origin has three planes associated with it, and we can come back and reference them if we needed to, but in this one we'll still add a mid-plane. So a couple things. We have this triangle. We can create a polygon. We can circumscribe it or inscribe it. And for this one, inscribe is probably the better option because we do know the diameter that those three drilled holes are on, and that will give us points to create the holes. So we construct like a circle. We radiate from the center out, and I'm just going to tab in to get the number of sides on the polygon. And I'm going to add the dimension as we start to create some features here. So we do have this outside radius. Now I happen to draw complete circles, but then we can offset these lines to then be tangent. So let's add some dimensions. First off, we're going to keep this line horizontal. We can drive the circles with a diameter, and that diameter is going to be 127. Either I can create the holes first, or I can create the radius. I'm going to put the radius in first, so it's a 16 radius, so 32 diameter. And I have three then drilled holes that are a 12 millimeter diameter. I now want to create lines of tangency. I can come back and I can offset this triangle at a given distance, and they're all going to be equal space, so I can just add a tangent relationship. Or can't I? Well, we know the radius. And the radius is 16. Let's try 16. And that will make these all tangent. one thing later on, we will not be able to find this. Oh yeah, we'll have the origin. We can trim. Instead of trying to come in here and select each individual area and maybe missing one, the trim tool, if there is a bounding body, it will allow you to trim to that adjoining body and really just in a means to clean up your sketch. You do not have to trim. You can still come back and select the individual areas. But trimming allows you to select line segments to remove them. I'm just going through here, taking off all the intersecting lines, and I'm left with this shape that I want to extrude. And this base material is 12 millimeters thick. I'm going to create the raised cylinder. So by having this origin in the center, I can come back and reference this, knowing that it's in the center. The diameter is 63.5 for the outside and an inside bore of 3810 is within tolerance. The overall height of this is 38 millimeters extended from the base. The bore is stated that it is 32 millimeters deep. Well, we just made this at 38. We have to add 6 millimeters worth of material here. I already have a profile. Don't have to create a new sketch. I'm just going to add 6 millimeters worth of material to create a bore depth of 32, where the cylinder is 38. Now to the ribs. I can reference a plane that is already in the program, and this one here would be down the middle, my YZ. But I'm just going to add a midplane. Two opposing faces, and I've created a plane down the middle. I'm going to sketch on this surface, and I'm going to create a coincident sketch. And line these two corners up. So now this is coincident, and we'll come back and add our 19 millimeter distance. Make a little mark here about that. No, I have something to measure too. What am I doing? And this rib is 19 millimeters. So from here, we will turn this into a rib. We know that it is 19 millimeters thick. I've had this problem before. If we change the depth, I would just start putting in, let's try 10 millimeters, it's going the wrong way. Let's go up a little bit. As long as we go over 19, we should be okay. And our thickness on the rib is 10. So by using depth, we can keep this problem where it extends all the way through from happening. And for this one, as long as we have a depth over 19 millimeters and not too large, we should be able to hit that cylinder. So we got our rib on, and now circular pattern. This feature, our rib was a feature, an axis. I can select the circumference, and I want it to happen 3 times, equally spaced, and I've created my ribs. So again, that board hole does not go all the way through, and it is a depth of 32. And we need some fillets that are a radius of 3. I'll pick the ribs. And one around this outside perimeter, and one around the base of the cylinder. A radius of 3. Why is one fading and one's not? Let's try that one first. See, that one faded out too. Let's try some more. That's better. And we'll put a couple more fillets on here. Oh, because this outside edge doesn't have a fillet. It's only the inner edge. There. Alright. So from our last project, we've been using ABS plastic, and now we're back to metal machine parts. So I'm going to change my material to cast iron and machine it. Cast iron, and we'll look for machined surfaces. So I have the bore that is machined. Holes are always machined. And the bottom surface is machined, back surface. There are no fillets around this back edge. So that should take care of the column support.